Welcome you all to this video lecture series. I am Dr. K. Bhuvaneswari, Assistant Professor, Department of Mathematics, Sathyabama Institute of Science and Technology, deemed to be University. Today in this video lecture series, we are going to see that in engineering mathematics, we have a topic change of order of integration in integral calculus. So in integral calculus, we have that multiple integrals. In multiple integrals, double integral you have, triple integral you have. So in the double integral, we have this change of order of integration. So it is the generalization of definite integral of functions of more than one real variable. If I consider that single integral, line integral, you have only function f of x or f of y. But if you have considered that double integral, we have the function of more than one variable. So double integral means we have two variables. So for example, here f of x comma y and we have f of x y z also. Integrals of a function of two variables over region R2 are called double integrals. The forms of double integrals are, the first form is this one. Double integral y equal to c to d, x is equal to b to a, f of x comma y dx dy. Since it is the double integral, we have function of only two variables, say f of x comma y. And look at the order, how we are going to integrate this integrand with respect to x or y. And see the limits always first. Whether the limits are constant limits or one variable limit or one constant limit, that I have to check always. So here both the limits are constant limits only. The next type of double integral is x is equal to a, x is equal to b, y is equal to f of x, y equal to g of x. So now you see that inner limits, that's for the variable y. So if the variable limit is given, so you have to give the preference first to the variable limit only. And this is for y, so definitely the function is going to be integrated with respect to y, and later you can go for integrating with respect to x. This is what the second type of double integral. And third type, that is what, y equal to c, y equal to d, and the next inner limit is for the variable x. X is equal to f of y, x is equal to g of y. So if this is for the variable x, so definitely you must to integrate the function f of x comma y with respect to x first, and later you can integrate with respect to y. Okay, so these are the three type of double integrals. Let us go to this in double integral. So if I have that constant limits, both the limits are constant, the order is immaterial. So either I can integrate with respect to x first or with respect to y. But you should not change the limit for the variables x and y, that we have to keep it in mind. So integral y to c, y equal to d, x is equal to b to a, f of xy dx dy is equivalent to the same. So here the order is immaterial. When I have the variable limits, so you must to see the limits and what is the order should be considered. So we will go for an example. So consider this integral type. Integral x is equal to a to b, y is equal to f of x, y equal to g of x, and whatever the integrand. And now look at what is your variable limit. That's for y is given. Y is equal to f of x, y equal to g of x. So you must to integrate the function with respect to what? With respect to the variable y only. And then you can apply the limit for the variable y. At last you will get the functions only in terms of x, and you may go for integrating the function with respect to x, and you can apply the limit. So we will see this one. Consider the double integral, integral 0 to 1, integral y equal to 0 to square root of 1 minus x square f of xy dx dy. So now you see the limits, whether all the limits are variable or constant limits. If the limits are constant, so we don't bother about it. We can do whatever order we want to take, we will take. But if this is given in terms of variable, so you must to follow the order. So what is this? This is the variable limit for y. So definitely I should go for integrating with respect to y only. So what we will do? We know what are the limits. That's for y equal to 0, y equal to square root of 1 minus x square. That should be taken as that equations. So the region is bounded by the lines x equal to 0, y equal to 0, and the line x is equal to 1, and the circle x square plus y square equal to 1. So we have 4 equations. What are the equations? X equal to 0, y equal to 0, x is equal to 1, and the circle equation, unit circle, x square plus y square equal to 1. So that should be taken in that xy plane. So I have considered this xy plane and I have taken all the 4 equations. X is equal to 0 is nothing but your y axis, and y equal to 0 is nothing but your x axis, and then the circle, unit circle. It is what? The circle with the origin is the center and radius is what? 1. So we have drawn the circle on that xy plane. Now what is given? This is for the variable y. So that we will check it. So what region I should take? So for that you have to see the limit of y equal to 0 to square root of 1 minus x square. It means you have to draw a strip parallel to y axis, that we will check. So y equal to 0, lower limit. Upper limit is what? It touching that a circle x square plus y square equal to 1. From that you know what is y, that's equal to square root of 1 minus x square, and look at it is the positive side, the positive quadrant of that xy plane. So positive side means you will take only this region. Okay, so now what I am going to do? I want to do the changes in the order. For that, what you have to do? So we have to draw a strip parallel to x axis, because I am going to find the limit for what? X variable. So you can draw a strip parallel to x axis. Actually the strip is started from the origin place and slowly it moves and it touches all the portion of the region. So now you see what is your left end of that strip. So where it touch? It touches that x is equal to 0, and the right end where it touch the sphere equation. From that I may find out what is x. What is x? X is equal to square root of 1 minus y square. So now what I know? I know the limits for x in terms of y. So lower limit of x is 0 and upper limit of x is what? Square root of 1 minus y square. Okay. Then what else I want to find? I want to find the limit of y, and that should be what? The constant limit. How I will find out? For that you must to get that x is equal to 0 in that equation, x square plus y square equal to 1, and from that you will get x square plus y square equal to 1, put x equal to 0, I will get y square equal to 1, from that y equal to plus or minus 1, but we are considering the only positive side, so you must to take y equal to 1. So we arrived the what? The limits. So limit of x is from 0 to square root of 1 minus y square, and the limit of y is from y equal to 0 to 1. So the main thing is how you are going to get the limit for either x or for y. Then come to the second one. Change the order of integration and evaluate this integral. Integral 0 to a, integral x is equal to y. Here it is not mentioned x is equal to y, but we have to identify this is for what variable. So x is equal to y, to x is equal to a, x by square root of x square plus y square dx dy. So what you have to do? You have to find the order and then you have to evaluate here. So now we will see that what are the 4 equations. Let us see. So I know what is that inner limit, that is for the variable x. So x is equal to y and x is equal to upper limit is what? A. then y equal to 0, y equal to a. So, all are written as a equations. Now, from these equations only, I am going to get the limit for y. So, how I will get that? For that, you must to draw this region on that XOY plane. So, now I have considered that XOY plane and I have taken all the 4 equations in that XOY plane. So, what is x is equal to y? X is equal to y is a line passing through the origin, and this is what y equal to 0, it is what my x axis, and x is equal to y we have drawn. X is equal to a, it is what this line, x is equal to a, that is parallel to y axis. Now I want to find out what is my region, either this region or this region. For that we can cross check what is that limit is given for x. So, x lower limit is y, upper limit is a. So, now I am taking this for trial only, I have to check. So, if I take that this integral, this region, if I draw the strip parallel to x axis, that will touch, that left end will touch x is equal to 0. But my lower limit is what? X is equal to y. So, I cannot choose this first region. So, only I will take this. So, let me check whether it is correct or not. So, now we have to draw, since it is the limit for x, I have to draw a strip parallel to what? X axis. You find out where the left end touch. It touches that line y equal to x. Yes. So, what is my lower limit? X is equal to y. That's correct. And what is my upper limit? So, it means you have to see the right end of the strip where it touch. It touches that line x is equal to a. So, that is what my correct region. So, first you have to identify what is your region where you are going to integrate. Okay. So, now I have identified, yes, this is what my region. Now, the next step is what? I want to find out the limit for variable y. So, given variable limits are for x, so we want to find the limits for y. So, for that what I have to do? So, again I am considering the same region in that on that XOY plane. Okay. So, now what I have to do? I have to get the limit for y. So, for that you should draw a strip parallel to y axis. Okay. So, remember, when you want to get the limit for y, you have to draw a strip parallel to y axis. Clear? So, yes. So, I have drawn the strip parallel to y axis and it starts from the origin and it covers all the portion of the region, slowly it covers. Now, you see that what is your end y equal to 0 and what is the top end, that is what y is equal to x. So, now I have identified the limit of y is from 0 to y equal to x. So, this is what the limit for y. So, after getting the limit for y, I want to find out the limit for x. So, limit for x means, so what you should do, I know what is that equation, x is equal to a. So, from this origin to that line x is equal to a, x covers. So, it means that we will see that what is the limit for y and x. So, the limit for y is now y equal to 0 to y equal to x. And then limit of x is from 0 to x is equal to a. So, we have identified the limits for x and y correctly now. So, now we will see what is that double integral. Integral x is equal to 0 to a. Now, we have changed the limit for both x and y equal to 0 to y equal to x. Then the integrand is what? X by square root of x square plus y square dy dx. And now, what I am going to integrate? This integrand is going to be integrated with respect to y. So, you remember, when I am integrating with respect to y, the variable x is treated as constant. So, you keep this x and you are going to integrate this 1 by square root of x square plus y square only. So, what formula I can apply here? It is integral dx by square root of x square plus y square equal to log of x plus square root of x square plus y square. So, this formula I am going to use. So, now I am using that formula here. So, I am keeping this outer integral 0 to a. Since x is the constant, when I am integrating with respect to y, you keep that x. Now take that integral of 1 by x square plus y square. Yes, that I have written. Since here it is the variable is what? Y. So log y plus square root of x square plus y square. At last what I am going to do? I am going to integrate with respect to x, and now I must to apply the limits for y. So what is the limits for y? Lower limit 0, upper limit x. So I am applying. When I apply that upper limit, that for y is equal to x, so take x here, already you have x square, then y is changed to x square minus lower limit. So what is my lower limit? Y equal to 0. So take y equal to 0 here, simply I will get log square root of x square, and then you have to simplify this result, and last you are going to integrate with respect to x. So that simplification is done here. And then now what is that simplified result? This is what my simplified result. So x going to be cancelled. Simply I have x into log 1 plus root 2, and log 1 plus root 2 is also a constant that should be taken out. Now only you have 0 to a x dx. Now you know what is that integral of x? That is x square by 2, and you are applying the limit for x is equal to 0 and x is equal to a. So you will get a square by 2. Lower limit is 0. So a square by 2 minus 0, or simply a square by 2 into log 1 plus root 2 is the answer. So this is the way to integrate the double integral by using that change of order of integration. Now you look at this question. By changing the order of integration, evaluate the double integral 0 to infinity, integral x to infinity, e power minus y by y into dy dx. And here they may give any order, but we should take clearly what order should be followed here. Okay. So now you see that inner limit, that is for what? Y. Y is equal to x, y is equal to infinity. So it means that the limits for y is given. Okay, and that lower and the next limit is what? X is equal to 0, x is equal to infinity. So first you have to identify these limits are what for given. First what we have to identify? We have to identify the limits, either it is given for x or for y. So that we have identified here correctly. Now you can write the 4 equations of that limits. So y equal to 0, y equal to infinity, x equal to 0, x is equal to y. Now I will take these 4 equations on my xy plane. So xy plane is taken, you know already x is equal to y is the line passing through the origin. So that line is drawn. Then y equal to 0, that is nothing but your x axis. What is then x is equal to 0? This is what your y axis. Y equal to infinity. So your y axis is extended till infinity. Okay, it's never end. So now I have shaded the portion. Okay, this is what the portion where we are going to integrate, right? So now what we have to take, we want to find the limit of x by changing the order. So we have to identify the portion, I mean what is the region, and you want to cross check, you can cross check. So what is that? This is the limit for y, means always you have to draw the strip parallel to y axis. So yes, I have drawn the strip parallel to y axis, and see the lower and the top where it touches. It touch that y is equal to x and y equal to infinity. So that's what that limit for y is given like that. So now I am going to change the order of integration. So for that what we have to do? We have to draw a strip parallel to x axis. So I have drawn a strip parallel to x axis, and see the left end, right end where it touch. The left end touch at x is equal to 0. The right end of that strip is touching that line y equal to x. So now what we identified? The limits of x is identified. So limit of x is from x is equal to 0 to x is equal to y. And what about the limit of y? So limit of y is from the origin to, it goes till infinity. So we have to take the limit of y is from 0 to infinity. We will integrate that double integral, integral 0 to infinity, 0 to y, e power minus y by y dx dy, and here this is what for the variable x. So definitely you must to integrate with respect to x. So when I am integrating with respect to x, you must to keep that y as a constant. So what is here? E power minus y by y. So that you can keep it as a constant, and only dx is going to be integrated. So integral of dx is what? X. So after integrating, we may apply the limits for x, lower limit 0 and upper limit y. So when I apply the upper limit, you will get y, lower limit 0. So y minus 0 means it is y. Then what happen? Y will get cancelled. So simply I have integral 0 to infinity e power minus y. So integral of e power minus y is e power minus y by minus 1, and then you can apply the limit for y. So take y equal to 0 to infinity, always the upper limit first, then e power minus infinity is what? 0, then minus e power 0, that's what? 1. So minus of 0 minus 1, it is 1. So this is what the answer after interchanging that order of integration to this problem. So in this problem, we have to change the order of integration only. So what is the question? Integral 0 to 4, integral x square by 4 to 2 into root x dy dx. So now what are the 4 equations? Let us find. That should be written here. Y equal to x square by 4 and y equal to 2 into root x. And this is nothing but the equation x square equal to 4y, and this equation is nothing but y square equal to 4x. And that limit for x is given 0 to 4. So now I want to get the limit for x as a variable limit. So for that you have to draw a strip parallel to x axis. So here I have drawn a strip parallel to x axis, and you see where the left end and right end touch. The left end touch the parabola y square equal to 4x. So from that, what is my x? That's y square by 4. And you see what is your right end, where it touch. It touches this parabola x square equal to 4y. From that you identify x is equal to 2 into root y. That is clear. To find the limit for y, we have to solve these two equations, x square equal to 4y, y square equal to 4x. So what we want to do? We want to get the limit for y. So I may square this y square equal to 4x. You will get y power 4 equal to 16x square. And x square, you know that is 4y. So that should be substituted here. Y power 4 minus 16 into 4y, that becomes 64y. And later we will take 1y. So you will get y into y cube minus 64, that's equal to 0. So from this you will get the lower and upper limit of y, that's what? Y equal to 0 and y equal to 4. So we found the limits for both the variables x and y, and the problem become integral 0 to 4, integral y square by 4 to 2 into root y dx dy. But in sometimes in the question papers or the problems, what will be given? Dy dx. But what we have to see? You have to see the limit. What is your inner limit? That's for variable y x, means you must to take the order x first. So here dx dy should be written. So we have to take carefully here. So in the next lecture series, we will see more problems of that double integral by changing this order of integration, and we will go for that multiple integral called a triple integral. Okay, thank you.